Now let's look at rotating a 3D object. We're going to use the cube because it's quite a simple one for us to get started with. So in order to generate a cube, we can think of the 4 points, so 1, 2, 3, 4, and we can join the 4 points together with 4 lines. Now we can also think about in the angle that we're looking at the moment, we're looking at it straight on in terms of the z-axis, so we're looking straight in here. All we're seeing is just the front face of this cube. But there's going to be a face at the back as well. So what we can do is we can pick another 4 points, and we can place those 4 points in the same x and y positions as these 4 points. So we're going to end up with 8 points. But in the second set of points, what we'll do is we'll shift the z component, and we'll shift the z component to a value of, say, -2. So in effect, what we are doing here is we're looking directly down onto this, in effect, Rubik's Cube. So if we set this Rubik's Cube on your desk, then you're going to be looking directly above it, down onto one of the faces, and you're going to have the other face at the back. But of course, whenever you rotate this, you're not going to have just the 4 lines at the back and the 4 lines at the front of your cube. You're going to have the lines that join each of those 2 faces. So you're going to have the lines here, okay, and also this line here. So we're going to have to join each of those 2 squares together. So in the end, we're going to end up with 12 lines. There's going to be the 4 at the front, 4 at the back, and the 4 that join them together. Now I've got those lines there, and I've got the inputs, and so if you open up the inputs there, you'll see that we've got the x0 and x1, x2, all the way up to x7. So x0 to x7 means there's 8 inputs, and you can check those positions for each of those within the program here. But you can see that for the first 4, we've got the z component is 0, and the z component is 0 here, and it's 0, and it's 0 here. So that's the front face of your cube. And then the next lot of z components, the x and y's are the same, but the next lot of z components, the position is z is equal to -2, -2, -2, and -2. So that's the inputs. We're going to have the equations. So again, there's going to be now 8 lots of these equations for each of them. Okay. And there's also going to be our 8 outputs. So that's our 8 outputs here. But I've turned the outputs off, so you don't need to see, you won't actually see the dots, because we don't really need to see the dots. And we've still got our angles are the same. Our beta z, gamma x, and alpha y. So let's go ahead and rotate this in the z-axis. So we're taking the cube and we're rotating it in the z-axis, but I'm actually rotating it round about the origin, which is this point here, which is the 0, 0, 0. So that's us rotating it in the z-axis, and that's working just as we would expect it to work. So now we'll rotate it in the x-axis, and we can rotate it in the y-axis. So finally, we'll let it run, and we'll rotate it in all 3 axes. So there we have our cube rotating in space in all 3 axes, and it's fixed though at this point here, which is the origin. So that's working quite well, although the way we've done it, the actual equations are set up within the tool are quite cumbersome, and it's not necessarily how we're going to continue through the rest of the videos, but it does give us a good understanding of where the 3D rotation matrix comes from. We've derived it and we've built up a few shapes, and we've been able to eventually build up a final simulation of a rotating cube.